This video is going to be over factoring a sum and difference of squares. We're going to start off with a difference of squares, just reviewing this real quick. A difference of squares, if you have something like a squared minus b squared, okay, a and b are any perfect squares and they're being subtracted. So to factor that, well, all we do is we take the square root of a squared, which is just a and a, the square root of b squared, which is just b and b, and then we have 1 plus, 1 minus, and that's all it is for factoring. So looking at our first example, we have ax squared minus 25y to the fourth. First thing you need to look for is that it is a difference, so that right there tells us it's a difference. So then you look at to make sure you have perfect squares. Well, 4 and 25 are both perfect squares. X squared is perfect and y to the fourth is perfect. From here, all we do is factor. So I want to take the square root of 4x squared. So the square root of 4 is 2. Square root of x squared is just x and x. Then we go to 25. The square root of 25 is 5. The square root of y to the fourth is y squared. 1 plus, 1 minus. We double check our answers to make sure nothing else can be factored. Any like terms? Nope, that's it. That is our answer. It's as easy as that. Looking at letter B, if you notice, 8 and 72 are not perfect squares, but there is a greatest common factor, a GCF, and it is 8. So I have to factor that out first, and it also is an 8y because both terms have a y. So I'm going to divide both terms by an 8y. My GCF goes on the outside. I write down what I have left over on the inside. So 8y cubed divided by 8y is just y squared. Negative 72y divided by 8y is a negative 9. On the inside right here, this is now a difference of squares, so I'm going to factor that. Square root of y squared is y. Square root of 9 is 3. 1 plus, 1 minus, and you can't forget your GCF on the outside. And that is it for factoring of difference of squares. The new one would be a sum of squares. Before we said it's not factorable yet, but we are in fact able to factor a sum of squares. So this does have a special case because of the plus sign. We have to use our imaginary friends to help us. So we will have i's there. Remember, I is the square root of negative 1. We will be using them for this. So when I notice I have two perfect squares being added, it's very similar to the other one. I take the square root of both of my terms, and I have 1 plus, 1 minus, but the only difference is now the b part gets the I. So this would be how we factor a sum of squares. So looking at letter A, I know I look first, there's no GCF. The square root of 9x squared is 3x. 3x, square root of 16 is 4. 4. 1 plus, 1 minus, but I cannot forget the i's with it. And that's it for the factoring. Okay, so it has to have the i's in order to be a sum of squares. Because when I multiply I times I, so I times I equals I squared. And if we remember, I squared equals a negative 1, which would help change the sign. And it would give us that positive that we need to be in the middle right here. So looking at letter B, again, I'm just going to factor it real quick. Square root of 49x squared is 7x. 7x. Square root of 81y to the fourth is 9y squared. I'm going to go ahead and put the I there. 9y squared I. 1 plus, 1 minus, done. That's all there is to factoring a sum and difference of squares.